Hi everybody, welcome to Study with Akshay and this is Akshay. In this video, we will be continuing the exercise 1 week questions and along with that 2 MCQs. So in the previous video, we were done till 7th question, right? So in this video, we will be starting with the 8th question of center of gravity with respect to center of gravity. So before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notification. So let's not waste time. Let's get started. Eighth question. Explain how will you determine experimentally the position of center of gravity for a triangular lamina or a triangular piece of a cardboard. So this is basically the diagram which we will be using and here is our explanation. So I will not be explaining in the form of a layman term. I will be explaining with a textual manner. As per the text, I will be explaining. So this is a procedure, experimental procedure. Take a triangular lamina. Make three fine holes at A, B and C. A, B and C near the edge of the triangular lamina. Near the edge of the triangular lamina. Now suspend the given lamina along with a plumb line from old A. So we know plumb line. So if you don't know what is a plumb line, it is given in textbook page number 14, determination of center of gravity of irregular lamina by a method of balancing using a plumb line. So you can just read as a storybook. So these kinds of questions will never be asked in your examination as well. Okay, this is just for your knowledge. Okay, no need to worry. I'm only saying no need to worry. Check that lamina is free to oscillate about the point of suspension. When the lamina comes to rest, draw a straight line along the plumb line. Plumb line is basically a rope with a weight over here. Okay, it will be a rope with a weight over here. Repeat the experiment by suspending the lamina through hole B and then through hole C, for which we will get straight lines by straight lines BE and CF. BE and CF respectively. It is noticed that lines AD, BE and CF intersects each other at a common point G. So this point is nothing but G, which is the position of center of gravity of a triangular lamina. That is the point of intersections of all the medians. Okay. So since this is experimentally, they have asked us specifically experimentally. Theoretically, it can be anything experimentally using plumb line only. Okay, next question. Let's go ahead. Okay, state whether the following statements are true or false. The position of center of gravity of a body remains unchanged even if the body is disformed. Okay, and then the center of gravity is freely suspended. The body always lies vertically below the position of suspension. For first one, it's a false. The position of center of gravity of a body of a given mass depends upon the shape, that is, the distribution of mass in it. And the next one is true. Since I have explained the plumb line method right now in the 8th question, it is true. Let's go ahead with the next question. If you think I'm a bit fast, so stop at the point, listen to it or go back, listen to it, make your notes and then move further. Okay. 10th one. A uniform flat circular rim is balanced on a sharp vertical nail by supporting it at point A as shown in this figure. So figure 1.42 is just given in your textbook. So this is the figure as given in the figure below. Mark the position of center of gravity of the rim in the diagram by a letter G. So just you have to mark. What is the center of gravity? So this is the point of center of gravity. Okay? Hope it's clear. Let's move ahead further. Figure shows three pieces of a cardboard of a uniformly thickness cut into three different shapes. On each diagram, draw two lines to indicate the position of center of gravity of G. Only two lines they have asked. Here is the two lines. The diagonals are drawn for a rectangle. For a triangle, two medians are drawn. The intersection of two medians indicates the center of gravity itself. And two diameters are drawn for a circle to indicate a center of gravity. All are indicated by a letter G. So yeah, we are done with the questions of exercise 1B. Let's go with the MCQ type questions. So multiple choice question. First one we have as the center of gravity of a uniform ball is at its geometric center, at the bottom, at the topmost point, and at the point of its surface. Uniform ball, that is a sphere. For a sphere, the center of gravity will be at its geometric center. Remember the table. Right. Next question. The center of gravity of a hollow cone of height h is at a distance x from its vertex, where the value of x is. So basically, for a hollow cone, it will be 2h by 3. So these types of questions will not be asked, and they will not ask you to explain also. They will not ask in the MCQ also. If they ask, just blindly answer this. This is a tip from my side. So these things are not given in our textbook as well. This is not related to physics textbook. Okay, so don't ever bother with respect to this, and this question will never be asked. If you want the explanation, please do mail me using the mail id studywithakshay65@gmail.com. Separately I will be explaining it to you. So in order to not to disturb the students mind, I'm not explaining it over here. So if you want a specific explanation, ask me through that mail ID. I will be explaining over there, or in the comment window you ask me, I will be explaining over there. Okay, so do get clarified. And yeah, we are done with exercise 1B. So hope you have liked the questions and liked the way I have explained. Please click on the thumbs up button. Please share this video. You can comment this video. You can post your suggestions, doubts, anything you wanted to ask with respect to this video using the mail ID studywithakshay65@gmail.com. So before ending this, in the next video we will be coming with uniform circular motion, that is the exercise numericals exercise 1C. Okay, so before ending it, please follow COVID appropriate behavior, wear masks, sanitize at regular intervals, maintain social distancing. Together, let's all fight against this COVID-19 virus. Stay home, stay safe. Thank you. Bye bye.